Hello everyone, let's go ahead and take a look at the next section, which is going to be called area. Now, by definition, area is the amount of two-dimensional coverage of a closed shape. Now, I think most of you are familiar with area, and the important thing is for us to remember all of the different initial statements that are needed in order for us to calculate area based upon the shape that's given. So for example, we have the area of a circle with a given radius is going to be equal to pi r squared. The area of a square is just going to be equal to s squared, where s represents the side. The area of a parallelogram is going to be equal to base times height. The area of a trapezoid is going to be equal to 1/2 times the quantity of base sub 1 plus base sub 2 times it by the height. The area of a triangle is going to be 1/2 base times height, and the area of a sector is going to be theta divided by 360 degrees times it by the area of the circle with a given radius. Okay, so these are the important initial statements that you have to know by heart, and you need to commit them to memory. Now, in order to solve complex area problems, it's often important to do two things, one or the other. One is break up the shape into recognizable shapes and then add all the areas of these smaller recognizable shapes. Or we need to go ahead and subtract areas from a larger shape that contains the original shape to make the original shape. Okay, so let's go ahead and take a look at how we want to solve for area problems for shapes that are just a little bit more complex. So let's go ahead and take a look at example 1 here. Here is what looks to be a shape that has this part here that's shaded and that part there is shaded, and we want to find the total area of the shaded parts. So what we're going to do is we're going to take a look at how to approach this problem from both method 1, where we break up the shape into recognizable shapes, then add the areas that we're looking for. Or we're going to take a look at method 2 as well, which is we're going to take a look at the bigger shape, which contains the original shape that we want, and then subtract smaller areas to come up with the area of the shaded shape that we have. So let's go ahead and take a look at method number 1. It says if we want to go ahead and take a look at the area of the shaded portions, okay? The area of the shaded portions in this case is going to be the area of triangle 1, and notice that I've written a red 1 with a circle in it so that we know exactly which triangle we're looking at, plus the area of triangle 2, which is going to be that triangle there. So notice all I'm going to be focusing on are the area of the shaded parts, and those shaded parts are of course recognizable shapes. So why don't we just go ahead and add the area of those two shapes. So what I have now is that the area of the triangle 1, remember that the area of a triangle is 1/2 base times height. That's going to be 1/2 3 times 10, plus the area of triangle 2 is going to be 1/2 7 times 10, because the base is 7 and the height is 10. So if I simplify that, that's going to be 15. Simplify that, that's going to be 35. If I add those two, I come out with 50 square meters. Now let's go ahead and take a look at the second method. And this is to go ahead and make sure that our shape is actually contained in a larger shape, and then take out the parts that we don't need. So here we go. If we go ahead and approach it from that method, what we're going to do is we're going to say the area of the shaded portions is going to be the area of the larger square. So notice the square is actually going to be containing all of the shaded area that we're looking for, and it is a recognizable shape. So it's the area of the square with the side equaling 10, because that's what the side of the square is, minus the area of triangle 3, which is this triangle right here. So notice that what we have then is that the area of a square can just be found by taking s squared. So that's going to be 10 squared minus 1/2 times it by the base, which is 10, and the height of this triangle, of course, which is 10 as well. So we have 100 minus 50, and sure enough, we're coming up with exactly the same solution of 50 square meters, because of course, the amount of shaded area is the same, regardless of the method that you choose. Okay, so kind of keep that in mind when we're working with area problems. is that you want to make sure to look at things that you recognize, look for those shapes, and then determine whether or not you want to go ahead and add the smaller pieces together, or you want to take a larger area and then take out area to come up with what you're looking for. Okay, now the one that I'm thinking that most people will not be too familiar with is this one right here, which is the area of a sector. And before we actually go ahead and talk about this particular initial statement, let's make sure that we define what a sector is. A sector is an area of a circle. Okay, so it's only with regards to a circle that is contained by two radii and the intercepted arc. Now, this is the plural form of radius. It's radii and the intercepted arc. So if we go ahead and take a look at this particular circle, notice that it is contained by two radii. So here's two radii right there, one radius and another radius there. And it is the area that is contained by those two and the intercepted arc. So where does the radius actually intercept the arc length or the circumference of the circle? Right there and right there. So it is all the area that is then going to be contained by the radius, and the intercepted arc. So it's that part right there. It's basically looking like a piece of pie. Okay, so what we have now is that if we wanted to go ahead and find the area of the green sector, then what I'm going to do is I'm going to use this initial statement which says that, okay, what is the angle, which is called the central angle, that is contained by the two radii? And in this case, it's going to be 90 degrees. So it's 90 degrees divided by 360 degrees times it by the area of the circle with radius equal to 3. And so notice 90 over 360 can be reduced to 1/4. Then the area of the circle with radius equal to 3 is pi times it by 3 squared. So we're going to come out to 1/4 pi times it by 9, or 9/4 pi square centimeters. Okay, sorry, let me go ahead and add one last thing. Okay, and so there you go. That's how we can actually go ahead and find the area of the green sector. Now, just to be very aware of what's happening here as well, is that you see this blue part, the blue dots, that area is also going to be considered a sector because it is also contained by two radii and the intercepted arc. So this area right over here would also be considered a sector. And if I wanted to find the area of that particular part, I would have to distinguish it between the area of the green sector by saying the area of the blue sector. So be very careful about which sector you are dealing with, especially when you're dealing with an entire circle. Okay, so let's go ahead and summarize again. In order for you to be able to go ahead and determine area, it's going to be important that you memorize all of these formulas, these initial statements for areas of recognizable shapes. If you come across a shape that is not necessarily recognizable, then what we need to do is we need to break it up into sections that are recognizable and then add the parts that we want, or look for things that is going to look for a shape, a recognizable shape that is going to contain everything plus what you're looking for, and then subtract out the parts that you don't need. And you have method 1 and method 2 there. Lastly, we need to go ahead and remember what a sector is and how it's defined, and also how to go ahead and find the actual area of a sector. Now the last thing that I do want to go ahead and mention is that remember that when we're dealing with area, we are dealing with the amount of two-dimensional coverage of a closed shape. So you're no longer talking about length, you're talking about square meters, square centimeters, or in the most general case, square units. So be careful about that as well. So we'll take a look at some of these area problems, and we'll go over them and see how you do. And if you have any questions, then let's make sure to talk about them in class the next time that we meet. Okay, see you later. Bye-bye.